Hey everybody, today we're going to be learning about section 6.11, which is on hydrogen fuel cells. So the learning objective for today is that you can describe the use of hydrogen fuel cells in power generation, and that you can describe the effects of the use of hydrogen fuel cells in power generation on the environment. For the essential knowledge, you're going to gain some information about what hydrogen fuel cells are and how they work, and then some of the pros and cons to them. So we'll start out with just some basics. So hydrogen fuel cells are going to use hydrogen as a renewable alternative fuel source to fossil fuels. So we're going to take hydrogen gas and oxygen. They're going to be the inputs that are used to generate electricity. And then the only waste product is going to be water. So the way that this works is we are going to have hydrogen gas entering a fuel cell. So in this diagram, this is the fuel cell. Hydrogen gas, H2, is coming in. And we are going to split the protons, the hydrogen ions, and then the electrons by use of an electrolyte membrane that only lets protons pass through. So what you're going to have here is you're going to have this hydrogen gas, and you've got this electrolyte membrane. And protons are going to be the only things that can pass through here, which means it's going to force the electrons through this circuit, which is going to generate electricity. And the protons are going to go through, so you're going to get hydrogen ions going through to the other side of this cell. Now, oxygen is going to be entered into this fuel cell. It is going to break apart the two oxygen atoms from the O2 gas. And what's going to happen here is you're going to have two hydrogen ions combining with one oxygen atom, which is going to create water. So this is why you are going to get water as the only byproduct, which is going to be the only emission that comes from these hydrogen fuel cells. Now, the most common application for hydrogen fuel cells is going to be with vehicles. It's going to theoretically replace gasoline, which is a non-renewable greenhouse gas releasing and air polluting form of fuel. And it's going to replace this with hydrogen fuel, which has no air pollutants released, and water vapor is going to be the only emission from it. However, at least at this point, hydrogen fuel cells are not widely used because fuel cells are very costly. So car manufacturers have not felt like it is worth it yet at this point. But the technology is out there, and we are starting to look more into it as ways to get costs down to make it a more feasible option in the future, hopefully. So one of the key challenges to this whole process is going to be obtaining pure hydrogen gas, because it doesn't just exist by itself as a gas naturally. So the way that we do this is by separating hydrogen gas from other molecules like water or methane. But this is going to be a very energy intensive process. And right now, there's two main processes that we will go through in order to get this hydrogen gas. And the first is going to be steam reforming, which is right now how we get 95% of all of our hydrogen production. And then the other option is going to be electrolysis, which is less common, but it is a more sustainable option. So the way that steam reforming works is you are going to burn methane, natural gas, and you are going to use steam to separate the hydrogen gas from the methane. So we're going to have this methane going in, air comes in order to cause this combustion reaction. Steam comes in, and then you're going to be having the hydrogen gas, and carbon dioxide is going to be a byproduct of this. So that's going to be a downside of the steam reforming method, is that carbon dioxide is going to be a byproduct, which is a greenhouse gas. And then also we're requiring natural gas, which is a fossil fuel, as the input here. Now, the other option, which, as I said, is going to be more sustainable because we're not using all these fossil fuels and emitting the carbon dioxide, is going to be electrolysis. And this is where you have an electrical current applied into water, which is going to split the oxygen and the hydrogen. Let's see if I can get my face out of the way. So if you've got this water here, you're going to have this membrane in the middle. You're going to have an electrical current applied through it, which is going to cause the hydrogen gas to split from the oxygen, which is then going to be released as hydrogen gas and oxygen gas. Now, we are not going to have any carbon dioxide emissions, which is definitely a pro of the system. However, it does require electricity to come in. And so this is going to have an impact on when we're talking about sustainability, like where is this electricity coming from? Because if this electricity is coming from burning fossil fuels, then this is not going to be as awesome in a long-term whole process sustainability because we're still using fossil fuels. But if it is coming from a renewable source of electricity, such as solar or wind, then this does make it a much more sustainable option overall, because then you're just kind of eliminating the whole fossil fuels from this process, and we are not having the greenhouse gases being a thing that is coming out of this. So we are going to talk about some of the benefits of having hydrogen as an energy carrier. So you might think, okay, well, why is this even a system that we're talking about if we are having to use electricity to get electricity, and this electricity can still be harmful or it can be not as good? And I'm going to explain like why this is considered one of the best future potential things when it comes to using it for electricity. And the reason why we have scientists even wanting to look into this as an option is because hydrogen gas can be stored in pressurized tanks, which means it can be transported for use in creating electricity later in a different location. So you can go through this whole process of creating this hydrogen gas and then use it later, which is often not something that we have an option for. For example, if we're thinking of solar as a renewable energy, you don't have the sun's rays in the middle of the night, and so you can only really use it when you have it. Hydrogen is going to be a great option because you can produce a bunch of it and then store it for those times when you need it later. And so the ability to store our fuel and future electricity is something, it's one of the bigger downsides to renewable energy and also just energy production in general. So this is why it matters as a potential thing. So we are not having to use it immediately. Another benefit of this is that you can generate it in one place and then transport it to another place. So if we're looking at like wind or solar or hydropower, you're having to kind of keep it all in the area. That's why here in the Pacific Northwest, we use hydroelectricity, but areas that are far away from us are not going to be able to benefit from that. But you could have this big production area where you're making this hydrogen gas, and then you can transport it to places far away so that they can then have access to this more renewable resource. Now, theoretically, this would also be awesome because it can be used as a fuel for vehicles and replace gasoline, which we know all of the problems that are coming from gasoline and the fossil fuel and the carbon emissions and all of that. And it also can be used to create ammonia for fertilizers or in the chemical industry. So as a gasoline replacement, it's great because it doesn't emit any air pollutants like the NOx or the particulate matters, and water is going to be the only emission from it, not carbon dioxide. Now, remember that water is technically a greenhouse gas, but because of the water cycle and the fact that it only stays in the atmosphere for limited amounts of time, we don't consider it as bad as carbon dioxide that can just keep building up in the atmosphere and contribute to warming. So although water is technically a greenhouse gas, we don't think of it as damaging as carbon dioxide. So having water be the thing that's being emitted is definitely a better option than carbon dioxide. Now, you can also then use this process to manufacture hydrogen gas, which can be used for a lot of different industrial chemicals. So you can make this hydrogen gas, which can be used for electricity generation. It can be used as fuel for vehicles. It can be used for fertilizers. It can be used in the industrial chemical industry. And so theoretically, if we can get this system down, it has so many potential benefits for it. You can store it as a liquid or as a gas, and so it's going to be really easy to transport to all the different places where we could use it. Another benefit is the fact that hydrogen fuel cells are going to be about 80% efficient in converting chemical energy in that hydrogen and oxygen into electricity. If you remember a while back when we talked about coal is only at 35% efficiency. So being at about 80 is going to be getting way more bang for your buck in terms of energy production. Now we're going to talk about some of the drawbacks. So, as of right now, since 95% of this hydrogen gas production requires methane, the hydrogen fuel cells are based on a non renewable resource. Methane is a fossil fuel, it is non renewable. And also, it is releasing carbon dioxide, which we have learned is not going to be a good thing to be releasing as a greenhouse gas. Now, the dream, theoretically, would be if we could have a more sustainable electricity source for this process. If we are able to use electrolysis, then it's going to be as sustainable as the electricity source. So, in a dream world, we would have wind and we would have solar, which can be used as the electricity input for electrolysis. And then electrolysis is going to be our more sustainable option for getting that hydrogen gas. And then if we can have that hydrogen gas, again, we can use it for all of the different industries that I talked about on the last slide. So if we could have electrolysis be what we use and it could be a sustainable energy source, then this is just kind of like an awesome dream of a really renewable way of getting our fuel. Now, one of the other drawbacks is the fact that, let's say we start using this, we start having more cars that can have these hydrogen fuel cells. Right now, we have a pretty big network for using gasoline. We have so many gas stations. We're going to have entire systems set up for that. So if this were to become our new widespread form of fuel, then we're going to have to create a widespread fuel cell distribution network, similar to what we have with gas stations. So that's going to be quite an investment to get that up and running. And at this point, car manufacturers don't feel like it's worth it. Additionally, the hydrogen fuel that's going to be stored in gas would require much larger tanks than the current gasoline tanks that we have in our cars. And as of right now, they're very expensive to make. So car manufacturers do not feel like it's worth it at this point because they'd have to redesign their cars to deal with these larger tanks. It's going to be very expensive to do that. And so right now, it's considered a big enough drawback that not so many companies are wanting to dive into that. So what I want you to do for your practice FRQ for 6.11, you're going to practice the skill of explaining an environmental concept in an applied context. So what I want you to do is explain how hydrogen gas can be used to generate electricity. So that's going to be your practice FRQ for 6.11, and those were your notes on 6.11 about hydrogen fuel cells.